segments you call as a phases. So what are those phases of a compiler? First, we have a source program. We have a that is lexical analyzer. So lexical analyzer is the first phase of the compiler. So that first phase of the compiler. So it is taking a source code and produce some certain kind of output and feed into the second phase, that is syntax analyzer. We have a semantic analyzer, then we have an intermediate code generator, we have a code optimizer, we have a code generator, and finally we will get the target code. Now how many phases are there? 1, 2, 3, 4, 5, 6 stages are there. So these 6 stages we call it a phases of compiler. So this is very, very important. You can expect a question from this. Explain the phases of compiler. So I'll recall once again. What are the phases of compiler? Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, code generator. Right? What is the input as the first phase of the compiler? So source program, it is in the high level language, and we will get the target code, that is a low level language, we will get an output. Right? That is target program. So now that we have seen different phases, each one of them we have discussed it in the separately. So we will take the first phase. In addition to before starting each phases of compiler, we have 2 more communicator. Each phases produces some output and also error. So this output and error intermediate result, you need to be stored some storage. That storage is called as symbol table. That means each and every phases are stored in symbol table. Symbol table. Okay. So are stored in symbol table. At the same time, each phase of the compiler produces an error which is stored. How do you handle those errors? You have to use the error handler. That means each phase transfer the source program from one representation into another representation. Okay. So they communicate with error handle. As I said, each and every phase have a produce some error. That error is handled by error handler. So once you get will not be with error, will not continue to the next phase, will not go to the next phase, will be stopped there and notice the error to the user. User have to identify those error and recorrect it and send it, come back and compile again. So if the things are correct, the result he got will be stored in the symbol table and then will given into the next phase compiler. Then also they communicate with the symbol table. As I said, it's a symbol table, you have to store that. Okay. Okay. So now I'll take the first phase of the compiler. First phase of the compiler is a lexical analyzer. It is also called as a scanner. So it takes a program in a character by character. So it reading a code in line by line. So that before taking that line by line, it scan character by character. So those and produce the token. This will be the output of a lexical analyzer. Next. So now lexical analyzer reads the source program character by character and returns the tokens of the source program. These tokens are describe a pattern of characters having a same meaning in the source program, such as identifiers, operators, keywords, numbers, delimiter, and so on. So that means your source program, it may have many things. Either it can have identifiers or operators or keywords, number, delimiter, and for loop and conditional statement, and many more will comes in the source program. So each and everything have a certain rules or patterns to identify the tokens, right? So that is called as a pattern. Okay. So now take one of the example. I'll take one of the example new. New is equal to whole plus 12. So I'll take one of the expressions or one of the simple statement from the source program, how lexical analysis convert into stream of tokens. It has tokens are converted like this. These are tokens. New is an identifier, which is new value. Then we have a assignment operator, that is also tokens. Then old value is also an identifier. Then plus additional operator 12 is a number. So this means how many tokens are there? 1, 2, 3, 4, 5. Total 5 tokens are exist in this expressions, right? New value is equal to old value plus 12. So token is each and every states or variables or expressions are treated them as a tokens. Okay. So once you get these tokens, puts information about identifiers in the symbol table. Whatever these tokens are either identifier or odd operators or number, will keep in the symbol table. How do you represent this? What pattern should you use it? So we already studied this in the ATC, that is regular expressions are used to describe the tokens. So that is also construct using regular expression to construct the lexical analyzer. So how do you construct? You have to use the deterministic finite state automata can be used in the implementation of lexical analyzer. So lexical analyzer already have done some few problems in system programming lab, right? So how do you identify the identifier and check whether the given expression are valid, arithmetic valid or not. So all those are studied in that. I'll elaborate this in the theory. So one is need to follow the regular expressions, using those regular expression to construct a lexical analyzer by using a DFA. So deterministic finite state automata. So now I'll take one more example. So what is that? There will be a number multiplied with an expression 111 plus minus 22. So now how this is treating it? So first it is number, yes, it is a number, 2, 3, 4 is a number, it is a compiler, then followed by there is a multiple operators, there is again a left parenthesis, this is also kind of tokens, then there is a number, again there is an operator, again there is a number, right, and there is a closing operator. So this is how many tokens are there? 1, 2, 3, 4, 5, 6, 7. 7 numbers are there in this. Okay. So now 7 tokens are exist. Now let us check whether this is a token or not. Will you get will you get the valid tokens? Now first of all, it is not a token. Why it is not a token? We have a two dots are there. Usually should not any decimal number should not have more than one dot. So it's not a number. So first of all, this is not number, and also this is not a identifier. Why? There is a special symbol. So it is not valid identifier. It's not a number. It's not a variable name. Why? It is having a hash. Okay. So now once it is understand the lexical analyzer, we'll go to the second phase of the compiler, syntax analyzer. Syntax analyzer is the second phase of the compiler. It takes the input from the lexical analyzer as a token and produce a syntax tree or parse tree. You have studied this already in the ATC in context-free grammar. So what is parse tree? So you already know that how do you construct a parse tree, what are the rules how to use it. So syntax analyzer create the syntactic structure, generally parse tree of the given program, isn't it? So syntax analyzer also called as a parser. So parse tree describe the syntactic structure. So how do you use that syntactic structure? You have to use the, as I said, you have to use the context-free grammar. Rules are mostly recursive. So most of the rules are recursive because you can use it more, so single rule more than once. So in such case, you call context-free grammar or recursive, isn't it? So syntax analysis also checks whether the given program satisfies the rules implied by the CFG or not, which is check whether the rules are not satisfied, definitely throw the syntax error, isn't it? So if it is satisfied, syntax analyzer create the parse tree for the given program. Otherwise, we'll go to generate the error by using error handler. So we'll see the example used to specify the CFG. So CFG is, so there is an example. An assignment statement gives identifier is equal to an expressions, right? So is equal to an expression. Expression can be identifier or number, right? Or expression is equal to expression plus expressions, right? How to create the parse tree? I'll take one of the example. First of all, I'll take a number multiplied with number plus number. So this have to be, first you have to This is one statement as given how to construct a parse tree for this. How to construct the parse tree for this. So now there is an expression with an operator. There is an expression again. Expression can derive the number. So there is operator. It is multiple operator. Then again it is an expression. Again expression can be expression plus expressions. So there is operators. So there is an expressions. Again there is expression with expressions. Then operator. Expression can be number. Operator plus this. This way it can be construct the parse tree. Parse tree. Okay. Now example, we'll say one of the example, real-time example. Let us find any error in this source program. Definitely you can find error in this. Yes. So merely can identify we are missing a increment operators. So this also there is an error. This also an error. There is a conditional operator, you can mix it, and there is return. Okay. Let us say that the extra parenthesis. Then there is a missing increment. There is a not an expressions. Then there is a keyword. It is a keyword. If instead of writing that keyword, if you return fi, so it is not a keyword. So these are all syntax error. Syntax error, isn't it? Okay. Let us move to the what is the difference between syntax analyzer versus lexical analyzer. Syntax analyzer versus lexical analyzer. Syntax analyzer, which construct the program, should be recognized by lexical analyzer and which ones by the syntax analyzer. So syntax analyzer, once you construct the program, should recognize by the lexical analyzer and it is only once, and which ones by the syntax analyzer. Both are similar things, but the lexical analyzer deals with a simple non-recursive construct. Once you read it line by line, convert to stream of token, will not use a more than one same pattern of the language. It is non-recursive. Syntax analyzer deals with a recursive construct. As I said, it can apply more same rule in more than once or repeatedly you use till you get the desired result. So lexical also simplify the job of the syntax analyzer. Lexical also recognize the smallest meaningful units of the source program. Syntax analyzer works on the smallest meaningful unit in a source program to recognize a meaningful structure in our programming language. Now, once it is over, we'll go to the semantic analyzer. Semantic analyzer, so it will take the input as a parse tree and produce the output also as parse tree in terms of intermediate representation. What is that value? Semantic analyzer, it check the source program or semantic errors and collect the type information for the code generation. So it check the semantic error and also collect the type information. If any variable declared in the source program, it's definitely any variables or method, it is definitely having a data types. A data type also should be checking by the semantic analyzer. If you are declared the variable as a int, this if you given it result input as a float, result will be written as a integer only. So you definitely will get the wrong result. So data type also plays important role. So that is also you have to check in the during the compilation. So that where the semantic analysis play important role. Type checking is an important part of the semantic analyzer. So normally semantic information cannot be represented by context-free language in a syntax analyzer. So this is not done by the syntax analyzer. Semantic analyzer, it does by syntax directed translation that we are studying in the 5th module. I'll tell you that. Okay, context-free grammar used in the syntax analysis are integrated with the attribute. So that attributes is a deal by semantic rules. The result, it is context-free grammar CFG plus attributes. Attributes together it is called is a syntax analysis integrated with attributes, semantic rules. So it deals with a semantic analyzer. The result is a syntax directed translation. So attribute grammar. So you should use the what are the rules. You see that new value is equal to old value plus 2. Type of this identifier new value must be matched with the type of the expression. So whatever that expressions of this type should be matched with new value type. If you declare this as a int, this also an int. So the type of the identifier new value must be matched with the type of the expression old value. So take the semantic analyzer in this. I will take one of the value. So here it is. Let us see that type not declared. You have not declared the type in this because all this I have not declared. K value I have not declared. Int ij I have declared that, and return type is mismatch return type because j integer data type. Okay, here it is a declared, this is an int, but it's a pointer integer. Here it is return type is mismatch, and this uninitialized variable x has not initialized it, so it is initialized to some value. So variables, and n is undeclared. So these are all semantic errors. Now parsing technique. There is a parsing technique. We have two different parsing technique. So one is top-down parsing and bottom-up parsing. What do you mean by top-down parsing? Construction of parse tree start at the root and proceed towards the leaves. That is top-down parsing or top-down parsing approach, which is efficient. Parser can easily constructed by hand. It can be constructed by hand. Recursive predictive parsing, non-recursive predictive parsing, it comes under top-down parsing technique. Bottom-up parsing, construction of parse tree, start at the leaves and proceed towards the root. So this is reverse of top-down approaching, but normally efficient bottom-up parser are created with some software tools, that automatic tools are using it. Bottom-up parsing also known as shift reduce parsing. So this is also very important. We'll study in the later case. Operator precedence parsing is nothing but very simple, restrict, easy to implement. There are two techniques that comes in this. LR parser, SLR parser, LALR parser, but we'll study only SLR parser in your course. So LR and LA are not included in this course. Earlier it was there, but not now. Okay. Now intermediate code generator. Intermediate, once it is get the intermediate code generator, so it will take the input of the input as a syntax tree and produce the intermediate result. So what do you mean by intermediate? A compiler may produce an explicit intermediate codes representing a source program. So once you get this, intermediate code generally machine architecture independent. As I said, this intermediate code generally machine independent. Both, but the level of intermediate code is close to the machine code. So in the other case, as I said, there are machine independent and independent. Independent means, so whatever the codes are there, after IR, you can use it for any target machine directly. You can develop your own code with respect to different target machine. But if it is a dependent, you should always use it. These intermediate code generally machine independent, architecture independent. So you take this, how do you convert this? One of the value, I will take a piece of code, new value is equal to old value, multiply fact plus 1. So obviously as I said, it is a identifier, ID1 is equal to assignment operator, which is assignment operator. Then again it is a old value as an identifier. So ID2, again there is an operator, multiplication. Again this is an identifier, ID3 plus there is a number. So you will retain as it is. So now we will get the ones we have stream of tokens are generated. So we have used the quadruple. There are different 3 address codes are there, or intermediate codes are there. Quadruple, 3 address code, triple, indirect triples. We'll discuss it in 5th model. So now I'll tell you that there is an operation. It is a target code. Target code. So this is a target code. First it have to multiply this. Multiply ID2 with ID3 stored in temp1. Okay. So now add this temp1 with direct 1 and stored in the temp2. Then move temp2 ID1. So whatever that result is stored in the temp2 and stored finally in ID1. Once you get the intermediate, so there is a next phase of the compiler is a code optimizer. Code optimizer optimize the code produced by the intermediate code generator in the terms of time and space. See, everybody are writing or designing a code or compiler, but how effectively writing or designing compiler is very important. So someone is writing a program in 100 line with the same result you will get. Some other one will write a code in 10 lines, the result will get in the same way. But so 10 line is more effective. I cannot be say that is 10 line 100 lines, but I'll tell you in terms of compiler design, so more effective way of writing program and utilizing a memory and faster the compilation, it is very very important. 100 of lines are definitely occupy the more space, it will take a more time to compile, so this is a waste of time. Compiler will not get the more performance, so fast performance. So in that, in order to optimize your code, the code optimizer come into picture. Code optimizer optimize the code produced by the intermediate code generator in the terms of and time and space. Let us see that. So I have used the 3 instruction previously. Now I use it only 1. Instead of moving id 1 to this, directly I move id 1, id 2, id 3 are multiply and stored in the temp 1. I am adding temp 1 and stored directly to id 1. How many temporary variables are generated previously? There is a temp 1 and temp 2 are there. This is simple temporary variables are there. It is system generated variables. So suppose it is small here, there are 2 temporary variables are there. You look at the last together line of codes, programs, how many temporary variable will be generating. So in order to avoid those temporary variables occupy the memory, you have to save the memories space. So this also, it is, look at the optimizer, will optimize it. There are different optimizing techniques are there. This is simple program. Look at this semicolon, there is a same thing will be saying, and x is equal to 0, y is equal to 0, and for loop will be generating like this. So this is definitely I will explain while explaining a optimizer techniques. Okay, let us move to the next one. Code generator. So once a code generator produce the target language in a specific architecture, the target program is normally is a relocatable object file containing a machine code. So relocatable object code, that is already you know that our code will be occupied in a different piece of codes are occupied in different locations. So but all have the links, as and when it required it can be linked and unloaded for the memory for execution. So that is how to generate the code. Once you get the optimized code, it will given into the code generator, code will generating it. So id1 will be moved to the r1, multiply id1 with the r1, finally are stored in the r1 only, add that 1 into r1, so that again it will be stored the values in r1, finally move that r1 to id1. This is your target code is generated. So this is where it will be generating entire things. This is very difficult to understanding. These are all machine codes. So as per I explained this in the theoretically previously, whatever I given it in the assembly level language. So this I'll tell this in the other 2 factors, 2 points are missing it in this spaces of compiler. As I said, it's a symbol table. Any identifiers name and variables, constant, function are stored in the symbol table. So which are all, it is very important. Intermediate store values are stored in the symbol table, which is used for the further process. Okay, so this is one of point. And how to implement this? This access every phases of compiler. As I said, the scanner and parser, semantic analysis, intermediate code generator. Mostly use the how to implement this by hash table for efficiency. And error handler, as I said, it is also communicated in the each and every phases of compiler. And as and when you will get error is generated, it will be stop the thing process and notice the error to the user. User again you have to identify, and it can does this work in dynamically also. Okay, compiler need to detect, report and recover from error found in the source code. This is very important. So this also, there are different error techniques are there. I'll tell you how error can be recovered. Error handler, I'll explain it in the later classes. Error handlers are different in different phases of compiler.